Greetings and welcome, G-Amigos from across the world. We gather today to prove triangles congruent in a far more efficient pattern than trying to show that all of their corresponding sides are congruent. And the first congruence, they call it a postulate here. Could be a theorem, depending on how you, whether you believe it needs to be proven or not, is side angle side, which is making this claim. If two sides and the keyword included angle of one triangle are congruent to two sides and the included angle of a second triangle, then triangles are congruent. So the key idea is that the angle is the included angle. It's right in between those two sides. Right? That's the mandatory step right there. So I drew this little picture. You could add that to your Foldable Notes if you wanted to. And we'll take a look at some of these problemas in just a moment. So here we go. This is the idea. Side angle, side. Included angle. This would be a non-included angle. This would be a non-included angle. Included angle is the in-betweenest angle, right? There you go. So let's see. Here's some problems, and notice they're a selection of the ones found on your Foldable Notes. So you can just kind of open up the whole thing, and let's take a look at question 1, which I picked for no particular reason. Other than that, it works with side angle side. But here we go. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulate you would use. So notice, presently, I happen to know this side is congruent to that side, and I happen to know this angle is congruent to that angle. That's like an SA or an AS. I need another side here, people. Does anyone see a side that I could show congruent? Well, BC might be congruent to AD, but I don't know if I've got a way to... Oh, ED BD. BD is congruent to itself, and I realize you guys don't have a lot of space to write that. My apologies. But you can at least label the diagram as such as you're putting your cell phone away. BD is congruent to itself by the reflexive property, which is this wonderful reality in which everything is itself. Yeah, it's nice to live in a world in which that's the case. But are all people congruent? But I agree, all people value. But congruent? That's hard to prove. Even if you knew that they had two sides and an included angle congruent to someone else, I don't think you could prove they're congruent. Yeah. So because I now have this, I think I can say triangle ABD is congruent to triangle CDB, and the reason is SAS, side angle side congruent. All right, so if those things are congruent and it's the two sides and the included angle, then these triangles are the same. Right? So let's take a gander at question 3. All right. So presently, I have AB and CD are congruent. I've got BF and CE are congruent. So I've got two pairs of sides. It would be great if I could prove congruence of maybe their included angle. Notice in this case, I happen to have that this is a right angle. I know that this is a right angle, right? That those lines meet perpendicular. If this one's right, then the one opposite of it, or a linear pair rather, with it is right. So put your cell phone away. I think I could say angle ABF is, and for some reason I just wanted to say alcohol, tobacco, and firearms, but that's not, yeah. I don't know. Actually, yeah, I always try to, you don't try to guess a cool name for the acronym of the thing? Like, actually, maybe the government should regulate backhoes more. I don't know. So angle DCE, maybe? There we go, DCE. Why are those two right angles congruent, friends? The right angle congruence theorem. Racked! Yeah, that's why. That's what I say. Yeah. So here we go. That means I could now say these two triangles are congruent to each other. And I'm not liking my triangle shape right there. So triangle ABF is congruent to triangle DCE. By the what? The why are those congruent? Well, I've got two sides and the angle in between. So I'm going to have two sides, angle in between. SAS. Yeah. Which is the only one we're focused on today, but there will be more three-letter combinations of S's and A's that will prove triangles congruent wonderfully. Wonderful. Maybe if we're in the world of quadrilaterals. I mean, technically, you could say angle side would prove two triangles congruent, but this would just not have been necessary. It would have been additional information that wasn't required. I mean, we did have like the 6-letter combination, which was the prove all corresponding parts are congruent. But yeah. Hey, check this out. Here's question 6. This one's a little bit tricky. So notice I've got a 3 plus a 1. I can actually view that, this entire segment, AD, using kind of segment addition postulate, that AD is equal to whatever the 3 plus the 1 is. And I know that's super, like, informal, but you don't have the space to write down more of a proof anyway, so deal with it. AD, I think I could say is congruent to FC. All right, which is also a 3-segment and a 1-segment combined. Are you guys seeing that? That those two longer segments are congruent to one another. It kind of ends up using a combination of segment addition postulate, seg add post, and probably a little bit of def of Kong and some substitution. But yeah, seg add post is the main way that I would have proven that. Similarly, notice I could find the length. I'm not a fan of that curly. That one's a little better. I can't go there yet. I don't know what CD is. Let's see, Charlie Daniels. I'm going to say CD is congruent to itself. Yeah? Why is CD congruent to itself? Yeah, good old reflexive. And then using seg add post, I could, do this piece plus that piece is that entire thing. And this piece plus that piece is this entire thing. So I think I could actually say BD is congruent to... You guys agree with that? This part is the same as that part because they're the sum of the same length. So that's also kind of a seg add post and some substitute f of Kong, but we're just like abbreviating super simple right now. And also, I happened to know that angle delta and angle Charlie were labeled congruent. Now, there's a lot of like crazy colors and things that I've doodled on this, but can anyone tell what's going on here? Oh, let me see if I could actually, maybe I can draw on the side one of these triangles. Sometimes it's helpful to separate them out and realize, oh, I've got a side, an angle, and a side, right? Side, angle, side. And then similarly for the other one, I've got a side, two sides, and their included angle. I actually like the way the simplicity. So, yes, I could prove those triangles congruent by side, angle, side. All right, that one would have required probably like 12 steps in a 2-column proof, which would not be fun, and you don't have the space on your Foldable Notes. So triangle ABD was triangle FE. There. All right. Well, I think that's all we'll do today for this, internet friends. Thank you for watching, and I hope you enjoyed a video that was exactly 10 minutes and 6 seconds.